Welcome back to Bot Thoughts by Amtalk Soft. I'm Alex. Quick question to start us off. If your AI agent burned $340 in 6 hours retrying the same prompt, how long would it take you to notice? For one of our listeners, the answer was 4 hours and a pager that went off at 2:47 in the morning. That story landed in our inbox last week, and it is not unusual. The biggest dev complaint on Reddit and Hacker News this month is the same theme over and over. Agents fail silently. They do not crash. They do not throw exceptions. They just quietly produce garbage, or quietly drain the API budget, or quietly skip the step that mattered. Today, we are sitting down to talk about why that happens and what to actually instrument. With me again is Sam. Sam, how widespread is this?
It is the dominant production failure mode in 2026. The reason is structural. A traditional service either returns the right answer, returns an error, or times out. 3 states easy to monitor. An AI agent has a 4th state, which is returns a confident wrong answer, and it has a 5th state, which is takes 19 tool calls to do something that should have taken 2. Both of those states look like success on the outside. The HTTP status code is 200. The trace shows a completed run. There is no stack trace anywhere. The thing actually went wrong inside the model's reasoning, or inside the tool selection logic, or inside a retry loop the framework helpfully added. Conventional observability tools were never designed to detect any of those. So you end up with a Datadog dashboard full of green checkmarks while customers are quietly receiving wrong invoices.
Walk me through that $340 bug, because I want listeners to recognize the pattern in their own code.
The pattern is almost always the same. You have a multi-step agent, in this case a LangGraph workflow scraping earnings reports and summarizing findings. The agent makes an OpenAI call. OpenAI returns a 429 rate limited. Some layer in the stack, often the framework, sometimes a wrapper the team wrote 2 sprints ago, decides to retry. The retry succeeds, but the retry counter never resets. So the next 429 triggers another retry, then another. Pretty soon you have an exponentially growing retry storm hitting an 8,000 token prompt every 30 seconds. Each retry costs about 12 cents. 6 hours later you are at 340. Nothing crashed. The agent's external behavior looks like a slightly slow run. The fix was 3 lines. The detection took 4 hours of log archaeology because the team did not have token cost emitted as a metric, only as an after-the-fact billing line item.
You mentioned 5 states: confident wrong answer, excessive tool calls, plus the usual right/error/timeout. Are there other silent failure modes worth naming?
There are about 7 that show up consistently. 1. Hallucinated tool arguments. The model confidently generates a parameter the tool does not accept. The tool errors. The model generates the same wrong parameter again because nothing in the system tells it to stop. 2. Infinite reasoning loops. The agent thinks, then thinks about its thinking, then thinks about that. React-style agents are particularly prone. 3. Context window truncation. The framework silently drops the system prompt or the early tool results because the conversation grew too long, and now the agent has no idea what its job is. 4. Partial tool execution. The tool call succeeds for the first item in a batch and fails for the rest, but the agent reports success. 5. Tool selection collapse. The agent always picks the first tool in its list because the descriptions are too similar to disambiguate. 6. Latency spiral. Each step takes slightly longer than the previous because the prompt is growing until you blow your timeout budget. 7. Cost drift. Costs creep up week over week because the average prompt grew, but no single deployment caused it.
Okay, so we know what to look for. What do we actually instrument with? There seems to be a religious war between using OpenTelemetry as the substrate versus using a purpose-built tool like LangSmith or Helicon or Phoenix. Where do you land?
It is not religious if you let go of the framing. They solve different layers. OpenTelemetry is the substrate. Use it for spans, traces, and metrics across your entire stack so AI calls show up next to your database calls and HTTP calls in the same trace. That is non-negotiable in production. Lang, Smith, and Phoenix and Helicon sit on top. They are evaluators and replay tools. They give you the LLM-specific lens, prompt diffs, token cost breakdowns, eval scores, replay against historical inputs. The pattern that works in 2026 is OpenTelemetry as the floor and a specialized LLM observability tool layered on top. The two should agree on the same trace ID, so you can pivot from a Datadog alert to a Lang-Smith replay in one click. Teams that picked one and ignored the other are the ones currently rebuilding.
What spans should an agent emit by default? If a listener takes nothing else from this episode, what is the minimum bar?
5 span types as the floor. First, the agent run span at the top, with attributes for the user input, the conversation ID, the agent version, and the final output. Second, an LLM call span for every model invocation with model name, prompt token count, completion token count, cost in USD, and latency. Third, a tool call span for every external action with tool name, arguments, return value, and a success or error flag. Fourth, a reasoning step span if you are using React style or chain of thought, capturing the thought text and the chosen action. Fifth, a guardrail span anytime you ran an output safety check with the verdict and the reason. Those 5 together will cover 90% of debugging needs. The second the team adopts them, you stop having those 4-hour log archaeology sessions because you can just open the trace and walk it.
Metrics are the other half. Spans tell you what happened in one run. Metrics tell you what is trending across all runs. What is the metric set?
8 metrics that catch most production issues. Tokens per request broken down by model and by route. Cost per request, same dimensions. End-to-end latency at the agent level, P50 and P99. Tool call count per agent run because that is your reasoning loop detector. Tool error rate per tool. Retry count per LLM call. Conversation length in turns and in tokens. And eval score if you are running automated evals on production traffic, even on a sample. The killer alert from that set is cost per request. If you alert on a moving average crossing a threshold, you catch the retry storm in minutes instead of hours. Second killer alert is tool call count. If a single agent run uses more than 15 tool calls, page someone. That is almost always a loop or a tool selection collapse.
Let us talk about replay, because that is the new pattern that did not exist 2 years ago. What does replay buy you, and what does it cost?
Replay is the single most useful debugging primitive for agents. The idea is simple. Capture every input the agent received, every model response, every tool result. Then you can rerun any historical session deterministically against a new prompt or a new model version and see if the failure reproduces and whether your fix actually helps. Lang-Smith does this well. Phoenix has a free version that does this. Some teams build it themselves on top of S3 plus a simple replay harness. The cost is storage and the discipline to capture everything, including the temperature and seed if you want true determinism. The benefit is that bug fixes become falsifiable. You stop merging fixes you cannot prove. And when a regression slips through, you can isolate which model version or which prompt change caused it by replaying the same 100 sessions against both versions.
Let me push back. A lot of teams hear all this and conclude observability is too heavy for their stage. They are running a single agent, 50 users, no production fires yet. Is this overkill for them?
Yes and no. The 5 span types and the cost alert are not overkill at any stage. They are about 10 lines of code with the OpenTelemetry SDK and the Open Inference Auto instrumentation, and they would have caught the 340 bug at any scale. What is overkill at 50 users is the full eval pipeline, the replay harness, the dashboards, the on-call rotation. Build those when you have a team. But every agent in production from day one should emit its trace, its tokens, its cost, and its tool calls. 3 lines of bootstrap, 10 lines of attribute setting. The teams that wait until they have a fire to instrument always wish they had not waited.
Give me one real example from a team you have seen recently. What did they instrument? What did they catch? What was the dollars and cents impact?
A mid-sized fintech, customer support agent, roughly 40,000 conversations a day. They wired OpenTelemetry plus Lang-Smith in a 2-week project. Within the first month, they caught 3 things. 1, a prompt change that increased average tokens per conversation by 41% because someone added an unnecessarily verbose system prompt. The cost graph caught it within hours of the deploy. Annualized save was about $90,000. 2. A tool that was returning paginated results, but the agent was only reading the first page, missing roughly 12% of relevant cases. The tool's span attributes made it obvious. 3. A model version bump that dropped eval score by 8% on their internal benchmark, which they only knew because they were running shadow evals on production traffic. They rolled back inside a day. None of those would have been visible without the span and metric layer. All three were caught within 30 days of the instrumentation landing.
Let us land this. If you are running an AI agent in production and you have done none of this, what are the 3 things to do this week?
3 things this week. 1. Install OpenTelemetry and the Open Inference Auto instrumentation for your framework. LangChain, Llama Index, and the Anthropic and OpenAI SDKs all have first-class instrumentation. 20 minutes of work gives you the 5 span types I described. 2. Set a single alert on cost per request that pages on a sustained spike. That alone would have prevented the 340 bug. Pick a number that is 2 times your current P99 and refine it later. 3. Set a ceiling alert on tool calls per agent run. Anything above 15 pages someone. That is your loop detector, and it is genuinely cheap to implement. Do those 3 this week. The fancy stuff, the eval harness, the replay infrastructure, the dashboards, can come later, but those 3 keep you out of the hospital.
Sam, what should listeners go learn next?
2 things. First, read the OpenTelemetry Gen AI semantic conventions. They are stabilizing fast, and adopting them now means your traces will still parse in 2 years. Second, read about agent replay specifically, separately from observability. Replay is the underrated half. Without replay, your fixes are just hopes. With replay, they are testable. If you want a longer read, there are 2 posts on Amticsoft, blogspot.com worth your time. One is the OpenTelemetry instrumentation deep dive, post 143. The other is on agent debugging patterns including replay, post 149. Both have copy-paste code.
That is our episode. If your team has a silent failure war story, send it in. We collect them and write the postmortems up anonymously. Reach us at hello@amticbot.com. If you got something out of this, the cheapest way to thank us is to subscribe wherever you listen, or buy us a coffee at buymecoffee.com/amticsoft. Next week, we are sitting down to argue about the MCP server gold rush, whether we are about to repeat the API marketplace mistakes of 2015. Until then, keep your traces clean and your alert thresholds tight. I am Alex, and this has been Bot Thoughts by Amtalk Soft.